Okay, let's move on to question 21. Again, we're going to find the first derivative of the function r of x, and then we'll evaluate at 1, the first derivative we'll evaluate at 1, 2, and 3. So the original function r of x is equal to 1 minus 3x squared, okay? So again, anything that is just a constant value is going to fall off in our first derivative. So we're going to focus on this next term. We take this exponent, bring it and multiply it in the front. So 2 times negative 3 times, bring our variable term down, x squared, and subtract a 1 from the exponent. So we have 2 times negative 3 gives us a negative 6 times x raised to the first power. So just an x, okay? So that is our first derivative. Okay, the next A, B, and C, it's simply evaluating this first derivative at the values given. So r prime evaluated at 1 is negative 6 times 1 gives you negative 6. R prime evaluated at 2, negative 6 times 2 gives you a negative 12. R prime evaluated at 3 is negative 6 times 3 gives you a value of negative 18. And we're done. Okay. 22. Okay, the function is f of x equal to x squared plus 2x minus 4. So again, any constant term is just going to drop off, and we're going to focus on the variable terms. So f prime of x, bring this exponent to the front and multiply. So 2 times our invisible 1 times x squared minus 1, and that's the first derivative for this first term, plus here we can write our invisible 1 there. You're going to bring that to the front. So 1 times 2 times x to the first power minus 1. So let's simplify all of this. F prime of x equals 2x to the first power plus 2, because again, this is going to simplify to 2x to the 0 power. Any term raised to 0 power is just equal to 1. So this is just 2 times 1. So 2. Okay? So now we're going to evaluate f. Okay, so we're going to evaluate f prime at 1. So 2 times 1 plus 2 equals 4. Then we're going to evaluate f prime at 2, which gives us 2 times 2 plus 2 equals 6. Sorry about that, guys. I got lost in my thought. So then f prime evaluated at 3 equals 2 times 3 plus 2, which equals 8. Okay? Problem 23. Okay, so an object is dropped from a tower 256 feet above the ground. The object's height above ground, x seconds after the fall, is represented by the function s of x equals 256 minus 16x squared. About how long does it take the object to hit the ground, and what is the object's velocity at the moment of impact? Okay, so the first thing we want to do is how long does it take the object to hit the ground? Well, this function is representing the height of the object. So if it's hitting the ground, this is equal to 0. Okay, so we're going to solve for that. 256 minus 16x squared equal to 0. I'm going to move this term to the right-hand side of the equal sign. So 256 equals 16x squared. Divide by 16 on both sides. That is, I don't know what that is. 256 divided by 16 is equal to 16. So 16 equals x squared. I'm going to take the square root of both sides, and that is 4 equals x. So it takes x represents time. This function represents height above the ground. So at 4 seconds, the object hits the ground. So let's answer part A. It takes 4 seconds for the object to hit the ground. Okay, so now part B, we want to determine the object's velocity at the moment of impact. So we are going to find the first derivative of our original function. So s of x equals 256 minus 16x squared. Again, constants, those essentially are eliminated in the first derivative. So we're going to focus on this variable term. We bring the exponent and multiply it in the front. So s prime of x equals 2 times negative 16 times x 2 minus 1. So that's going to simplify to negative 32x. So that's our first derivative. So now they're asking us the object's velocity at the moment of impact. So when this function is, so again, x is time, right? Our variables haven't changed, but we want to know the object's velocity at the moment of impact. So the moment of impact occurred also when x equals 4. So we're going to evaluate s prime at 4, which is going to equal negative 32 times 4, which is going to give us negative 128. So the object's velocity at the moment of impact is negative 128 feet per second. Okay. Next question. $24. The revenue in dollars from the sale of X car seats for infants is given by the following function. R of X, revenue, is equal to 56x minus 0.020x squared for values of x greater than 0 and less than 2,800. That's our constraint. Okay, so we want to find the average change in revenue if production is changed from 1,000 car seats to 1,050 car seats. Okay, so all it's essentially telling you is you want to find revenue at 1,050 minus revenue at 1,000 and divide it by 1,050 minus 1,000. Okay, so this is going back to like our basic algebra. Y2 minus Y1 over x2 minus x1. Okay, so we're going to plug in 1050 into our function for x, and we're just going to do that straight on the calculator. So 56 times 1050 minus 0.02 1050 squared equals 36,750. I'm just kind of writing it here over to the side. And then we're going to do the next part, evaluate R for 1,000. So 56 times 1,000 minus 0.02 1,000 squared, which equals 36,000. Okay, and then divide that by 1,050 minus 1,000 is divided by 50. So finish calculating the difference. Divide by 50, and that's equal to 15. Okay. Now part B is finding the first derivative of your revenue function. So R prime, actually let me write R of x here first. R of x equals 56x minus 0.02 x squared. I'm just dropping off all of these like extra zeros that we really don't need. I don't need this leading zero. I don't need this trailing zero. I'm just going to simplify my work a little bit. Okay, so both terms have variable terms. So I'm going to put my little one right here to find R prime of x. You take this number, you bring it and multiply it in the front. So 1 times 56 times x1 minus 1. Now moving on to the next term, we're going to bring this 2, bring it and multiply it in the front. But I also need to keep my operator here. So minus, negative, however you like to interpret this. So minus 2 times 0.02 times x squared minus 1. And we're going to simplify everything. So 56 times 1 is 56. This x1 minus 1, that's x raised to the 0. We know that's a 1. So this term is just 56 minus 2 times 0.02 is 0.04 times x. So this is our R prime. Okay? So then part C asks for R evaluated at 1,000. Well, we already did that in our previous work. So R at 1,000 is equal to 36,000. And then the next part here, R prime evaluated at 1,000. So we need to calculate that really quick. So R prime at 1,000 equals 56 minus 0.04 times 1,000. 56 minus 0.04 times 1,000 equals 16. So R prime at 1,000 equals 16. So now we're going to interpret all of this information. Okay, so at R, when you produce 1,000 seats, the revenue is $36,000, and it's increasing at the rate of R prime 1,000. So as you continue to produce that next marginal unit, your revenue is increasing by $16. Okay, so we can, by the process of elimination, we can also get B, because this B is telling us the revenue is R prime, and that's not correct. R prime is the instantaneous rate of change of revenue. R is the revenue. So B is wrong for this part of the statement. The revenue is R prime. That's not correct. Okay, here, the revenue is R at 1,000. So this part is correct. But then this part of the statement, it is decreasing at a rate of R prime evaluated at 1,000. Well, it's not decreasing because our value here is a positive value. So we know our revenue is increasing. So the only appropriate solution or interpretation is A. The revenue is R evaluated at $1,000 and it is increasing at a rate of R prime because again, you have a positive value here. So the rate is increasing. Okay, next question, 25. Here they're just asking us, this is a lot of funky notation. That's just dy over dx. That's just asking you for the first derivative of your given function. So dy dx for y equals x to the 6th power. And we're going to do the same thing we've been doing. So dy dx, we're going to bring this variable term, or I'm sorry, the exponent term to the front and multiply. So 6 times our invisible 1 times x 6 minus 1. So that's going to reduce to 6x to the 5th power. And you're done. Okay, problem 26. Same process, but now we're introducing some fractions in our exponents, so it just gets funky. So we just want to be neat in our work more than anything else, okay? So 26, we're given the function g of x equals x raised to the -1/2. And I'm just going to be really meticulously neat, okay? So again, we're finding g prime of x. I'm going to take my exponent, I'm going to bring it and multiply it in the front, and I'm going to multiply by this invisible 1 as well, okay? So -1/2, I'm bringing this exponent to the front, times 1 times x, -1/2 minus 1. So how can I also represent 1 in terms of a fraction? Well, I can represent that by simply writing 2 over 2. So I already have the same common denominator, and 2 divided by 2 is equal to 1. So it's just representing that -1 term as an easy fraction to deal with, okay? So now let's go ahead and simplify everything. So g prime of x is -1/2 times 1. So -1/2 x. -1/2 minus 2/2 is a -3 over 2. And we're done. Okay, 27. So same thing, find the first derivative. Y equals 1 over x raised to the 11th power. I'm going to make my life easy. I don't want to deal with this x variable term in the denominator. So I'm going to bring it into the numerator. When I do that for exponential terms, that changes this exponent to a negative value. Okay, and now I'm going to keep following the same process I've been doing. There's my invisible 1, my exponent, I bring it and I multiply it to the front, and then I subtract a 1. So y prime equals -11 times 1 times x raised to the -11 minus 1. So then I'm going to simplify that. So y prime equals -11 x raised to the -12th power. And we're done. Okay. Number 28. Same thing. Function f of t is equal to 2t squared plus 5t plus 9. This doesn't have a variable, so it's going to fall off. I'm going to put my 1 here. So f prime of t equals, I bring this to the front, I multiply it. So 2 times 2t, 2 minus 1, plus 1 times 5 times t, 1 minus 1. And like I said, the constant, it falls off. Okay, so now let's simplify. F prime of t equals 4t plus 5. Because again, t, 1 minus 1 is going to reduce to t to the 0 power, and anything raised to the 0 power is just equal to a 1. Okay, 29. Oh, 29 gets exciting. Okay. So let's start with our, again, funky notation. Find d over dx of the function is just telling you find the derivative of the function given within those parentheses set. Okay, so let's just call it y. Y equals 8x squared over 7 minus 7 over 9x squared. Okay, same thing here. We're going to make our life easy. We're going to take this exponent term out of the denominator. We're going to move it into the numerator, which changes this 2 from a positive 2 to a negative 2. So 8x squared over 7 minus 7x squared, 7x raised to the negative 2 over 9. And now we're going to do the same thing. The exponent we bring to the front, we multiply. Exponent, you bring it to the front, you multiply, and then you subtract 1. Okay? So y prime equals 2 times 8 times x, 2 minus 1 over 7 minus 7 times negative 2 times x, negative 2 minus 1 over 9. Excuse me. And now I'm just going to simplify everything. 2 times 8, 16, x over 7, negative 7 times negative 2, that's a positive 14, x, negative 2 minus 1 is a negative 3 over 9. And we're done. Okay, that was 29. Now question 30. Same thing. Give g prime of w if g of w equals all those random terms. And we're going to work through all these and simplify it a lot. Okay, so g of w equals 5 over 6w to the 5th power plus 8 and the cubed root of w. Okay, so again, we have our variable term with an exponent in the denominator. We don't like that. That's u. Let's simplify it. 5w to the negative 5th power over 6 plus, here we have 8 and then the cubed root of w. So whenever you have a root value, instead of doing a root value, we're going to turn it into the fraction of the root. So 8w raised to the 1/3. So I don't want this root value, this cubed root. I want to express it as a exponent as a fraction. Okay, and so now we can follow our same steps. Take the exponent, bring it to the front, multiply, subtract 1. Exponent, bring it to the front, multiply, and subtract 1. So g prime of w equals -5 times 5 times w to the -5th minus 1 over 6 plus 1/3 times 8 times w 1/3 minus 1. And I'm going to represent my 1 as a simple fraction. So 3 over 3. And now we're going to reduce all of our terms. So equals -25w to the -6 power over 6 plus 8 over 3 w raised to the -2/3. And we're done. We just have to follow our simple manipulation of exponents, change our cubed root into a fraction, and we still follow the same pattern. Bring it to the front, multiply, subtract 1. Bring the exponent to the front, multiply, subtract 1. Okay, so that is the end of Chapter 9 Test Review Part 3. Again, if you're getting lost in the process, let me know. Send me an email.